Actually, I forgot about the hardware section. I didn't do hardware. We'll have to do that separately. Oh, I can add it. I'll add it right now.
It's fine. It's fine. Alex, click on project as well. Okay. So, I think you've got one of your screens up, Rich.
Yes, I'm working on that. Hang on. Okay, almost there. Okay, I added a hardware section. Sorry. There's way too much to talk about here. Let me see if I can do this. Anything happening? Okay, here we go.
Yep.
Where'd it go? There it is. There it is. Okay, now we're heading to the cursor. Over here. Hang on, I've lost my cursor.
On the iPad.
Is that on the? Oh yeah, I've got an iPad too. Great.
Four screens.
Of course. Okay, put this over here. This over here.
So for those of you who haven't seen a variant of this presentation before, Rich has been tracking interesting research papers and developments and data around the growth of virtually every aspect of whatever this thing is, and piles them into a quarterly presentation, and then brings all the news stories plus any updates to thinking and signal that he's picked up over that quarter. So with that as background, I don't know, Rich, if you want to make some comment.
Well, first of all, Julian is way over marketed this presentation.
Totally.
I'm just one person. I actually have to say that I think it's the group collective that really makes the difference here. So this is sort of one person's opinionated view about what's happening, and it probably is certainly wrong. And maybe this can be a bit of an interactive discussion, since you gave me 2 hours this time, and I only know how to do 45-minute presentations.
I think it's two. Said two.
We always do what Paul says. That's the key. So this is in this continuing series of what's all this then about AI. Paul, I checked. This is now my seventh presentation of what's going on in AI. And every time I think things are going to slow down, they just accelerate again. So I just want to apologize to you for this. I think one of the, now, not all of this is about technology. This is against Paul's dictum that we can only talk about technology, but I just wanted to say that many of us are in startups, and how you sell this stuff is just as important as what the technology is. I'm going to put a little bit in about Rich Tom's learnings about how you talk about this stuff. And the reason I wanted to put this slide in is we use this a lot when we do enterprise presentations, because everyone feels so stupid about artificial intelligence to the person. I've not yet met a person who really, except for this gentleman over here, people who are deep into it, really get it. And what this slide actually shows is the world GDP from price birth all the way through the year 2024. And if you look at this, this is 1980. I just picked this because I started my first job then. That first dot is the world GDP in 1980. So the world GDP has actually increased by 40x in the last 40 years. So
hey,
just
Rick,
remember, we're all tuned.
Rick,
we're not seeing the slides, Richard.
do you mean to show a slide? You're showing a picture of somebody.
Last 40 years, it's incredible. The second dot is the year 2000. That was the global GDP, $40 trillion. So literally in the next 24 years, we basically doubled again. So we're at close to $100 trillion of GDP. So when you think about why we can't figure this stuff out, it's pretty simple. Things are changing more quickly than ever. And I think part of the reason I wanted to spend a lot of time talking about how to sell this stuff is, of course, people are confused. I look at the amount of change that's happening. The other reason is I think this whole discussion was very good. This is actually a chart where enterprises said, well, what am I actually using for my AI?
Oh, guys, we're not seeing any slides in Zoom.
Yep,
Okay.
same here.
Hey, Rich, all you were showing us was a picture
I
of a
need
very
to
handsome gentleman.
Zoom.
Have you,
I need to zoom, right? I'm not
Yeah.
to zoom.
I think
Paul, can you enable sharing?
No, because I'm not Zoom, so they can't see anything. So I need the Zoom link.
let me just add you to
Is it this keynote state of the art thing? I love the echo. It's lovely.
there's someone's coming to sort the echo. I think we're on the Zoom already.
It just logged in, I think. On it?
You should be. You should be.
Should be.
Hello,
I
hello,
can you
hello,
find
hello,
the screen.
hello, 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 hello.
Yeah, it says you've accepted.
Okay.
Just me.
I think that's my call.
That's the echo problem.
Hey, Rich, we don't see any slides. We just see a picture of a very handsome gentleman.
He's so good looking though. Come on.
Thank you. Appreciate that.
I'm gonna try to join this thing now. Oh, of course it's decided to put it over there because
There you go.
I think I can share directly here, right?
You should be able to.
Each AGI is
To share. Can people see anything?
Can remote people see anything of your screen?
Yes,
We
we're seeing
see
lovely-
what looks
lovely
like a
photo.
screensaver of your laptop.
Good, perfect.
Okay, can you see trans
That's good.
face?
Yes,
Miss
yes.
Lee's-
We can.
Okay.
Now we
And
see
a slide deck.
diamonds, Eureka, raining and
Oh my gosh,
Right.
life is good.
Okay, excellent. There we
And
go.
of course, this is the wrong presentation, so let's go find the right presentation. That's the last one.
I know. So getting better points of traction.
Okay, hang on 1 second. I'm almost there. Just gotta find my mouse.
It was over there.
See it?
I do too much first race.
Audio is chilled. And people about to see this? Seconds. Can everyone see this little slide?
Yeah, got it. Thanks.
Yes? How about this one?
Yes.
Okay, go. Okay, so this is actually an enterprise, and this is probably one of the big surprises of last year. I would have guessed that in enterprise share, ChatGPT would have been like 90% of it. A year ago, everyone thought that ChatGPT was it. Actually, you mentioned Cohere. Someone here mentioned Cohere. It's a good example. Everyone has a little bit of share. Right? And of course, there's a lot of trial going on, but it just goes to show the amount of confusion because a lot of these are startups. There's Mistral. I get rid of this.
Don't worry about it. Just go in.
It will go down.
Now. Okay. So there's Mistral, there's Bedrock. Amazingly, Llama, which really only shipped last June, has got actually quite a significant share already. Google's come back. Claude is, in many cases, a default choice for people. So there's a lot of confusion about what the right system is to use. So it's not like there's a standard, if I just use ChatGPT, that's where I am. So one of the problems, if you're an IT person, is, well, what am I supposed to pick as my single platform? Now, the second problem is even bigger, which is, I have to tell you that I thought that the number of papers was going to decelerate, but it's actually on an acceleration. So this is the number of papers shipped per month. And in 2005, so we all know there were about 1,000. Now there's about, last month there were about 11,000 papers shipped into archive. And so this confusion is why when someone says I'm summarizing all of AI, it is actually impossible. In fact, just this morning, Mistral just announced another new set of models that are supposed to be much better than Llama 3, et cetera, et cetera. So literally, I can't even keep up after finishing this at midnight. So that's how hard it is to keep track. So what I wanted to do was, because I don't like people who make predictions and then don't look back. So I actually went back to the June predictions and said how I'm doing, and then we'll talk about this thing. And the net thing is, I didn't do so bad. So there were basically 8 predictions back in June. And the first thing is that this agent stuff would become much bigger. And in fact, the agent stuff has become much bigger. The second thing is that at that point, there were only 10 models that were within any range of ChatGPT. Today, when I looked at LM6, which is one of the scoring things, all models are within range of ChatGPT, which is to say, if you would compare them head to head on a random question, ChatGPT would win roughly 60% of the time, and the other model would run roughly 40% of the time. That's a huge change, right? I mean, it used to be that there was only one model and everyone else was behind. The third thing is, there was a prediction that we would see a lot more refinements and the models would become smaller and cheaper, and that has in fact happened. I'm going to show you, just running on this poor little M1 MacBook, models that are more performant than ChatGPT, which actually have 0 latency compared to ChatGPT. And that's a huge change. Now, the question, of course, is, can you fit your problem into a small model? And this is part of the drive to basically make the prompts smaller, make the models work smaller, and so forth. The next thing was, and I love this question, if you have a prompt of, say, 10,000 lines, and there's a bug, like, what are you supposed to do about it? Right? This is the first time, my computer science degree is now, I hate to admit it, 40 years old. At least you could always find the line of code, right? And today what you do is you look at this gigantic prompt and people really start randomly hacking. It's like, well, maybe I have to delete this word. So one of the big questions is, how do you change from, and this is true with both trained systems and with soft prompted systems, how do you change it so it actually is reliable? I would say that I got a half on that because everyone wants it, but no one knows how to deliver it. I'm going to show you some techniques because this is all about sharing. So we're just going to open the kimono on everything we're doing. But some of the ways we're trying to manage these things so we get the reliability. And the punchline is, we've deployed our first enterprise system. We today run at 99% reliability. And most importantly, we will always say, we don't know. Because the biggest problem with these systems is you don't want them to say we don't know. So if you count don't know as proper answer, we're 100% reliable in our initial beta test with 10 customers. Right. So that is a very important engineering thing, and I'm happy to share how we do that. And it's not easy. The sixth thing we said was that there will really be a tale of two cities in terms of hardware. Now, Sanvanova is at the high end, for instance. The B100s are coming out, but there's all this ARM development. And that has in fact come to pass, which is the new ARM generation is unbelievable. Right? If you look at everything from the new Apple, the iPhone Pro 16 to the M4s, these things can run these models at amazing speeds with almost 0 latency and high predictability. In fact, you can, this is a 64 gigabyte system, but I can run 10 models all loaded into memory with 0 latency. And that's a sea change. And just to deliver our punchline, at Total Neural Enterprises, we plan on almost all of our developments to be client only. So we think that by going to small models and having this high controllability, we can actually package this up just like Office, right? And have the same reliability as Office. I will say that is a big sticking point for a lot of people. Like, where's my data going? How reliable is it? It is, and we all know that the easiest way to get infinite scale is to push it to the clients. And I hope that our AWS costs do go to essentially 0, because as you know, funding that stuff is very expensive. The seventh thing we talked about was safety and operations. This is really Paul's insights that people can figure out how to make these things safe and operate well are going to make a lot of money. And I totally agree with that. And I think that the industry doesn't have a really good answer for this, but if you get the small agents, you can do a lot more checking than before. So when you have a gigantic agent, how do you actually check reliability? If you have small agents, we actually run our system with 5 or 6 agents running the same query and then run a judge system. And then because you can run multiple models, you have a much bigger ability to essentially have separate code paths. Right? So this is the NASA theory that if I have 3 different systems running, the likelihood I'm going to hit the same error is much lower. The 8th one was, I think we call it, I looked at it, it's called dancing elephants. That is, everyone in the rooms over there from Microsoft OpenAI are all trying to lock us all into something, right? And that's, I work these companies, so I can tell you. And I think OpenAI has been the most open since they managed to publish their business plan. And so we know exactly what they're going to do over the next 5 years, which if you haven't read it, you should read it. It's very great reading. So average costs for customers are going to go from $20 a month to $44 a month, and hosting costs are going to go up by 10x. Because there are some people in this room who may have had these strategies, which is it's all free now, it's really wonderful, and then once you're locked in, you're locked in. So make no mistake, the battle I think for all of us as small companies is we can be on the side of customers, which is you don't end up in a day, and I just full disclosure, I talked to one customer, he's like, I don't see what the problem is. ChatGPT only cost me $2,000 a month. And every vision I had ever working in enterprise software, that is the dream. Don't worry, it's $2,000 a month. Don't worry about it, it'll be great. Because of course the business plan is it'll be $2 million a month as soon as I've got all the software in. Julian's point about owning the orchestration layer, if I was in a different staff meeting with these 2 guys, that's exactly what I would be doing. I want to make sure every line of code written by LSE and everybody else is written on my framework, controlled by me. And I want to make sure, of course, it's totally open, but I do want to make sure, of course, it runs better on Azure, Salesforce, and so forth. The other thing about dancing elephants, of course, is they're always going to tilt towards their system. So there's a Salesforce system, there's a Snowflake system. However, every enterprise has what? LSE must have 100 data silos when I talk to them. At least. And those are the only ones that are blessed by IT. They probably have 1,000. So one of our opportunities is to be that integration layer across all those things, because that's really what people want. So now I'm going to talk about predictions for October, and I'm just going to give you the quick summary because I was taught long ago, just summarize because no one's going to listen to the rest of it. But the first one is, actually, personal belief is selling and getting real deployments is actually the problem, right? And it's actually much harder. Leaving Paul, I love talking about tech, about Git repos and all that stuff. But most of the time I spend is, in essence, educating top management on why it is actually useful and how it's not going to kill you, right? Because this AI stuff is at that stage of like, no, I need to do something about it, but what? Right? And that's true for top execs. I was just talking to a mid-market safety valve company doing about $200 million in revenue here. And literally the CEO is like, I don't even know what to do. Like, where do I start? So I'm gonna talk a little bit about that, and I'm gonna share you our presentations. We're happy to share with anyone here how we do presentations. Maybe we can have a separate working group on how we get people to adopt. By the way, the biggest message I have for everyone here is, this man here, Paul, once told me, there's nothing more focusing to the mind than the sight of the gallows.
Originally, that was Dr. Johnson.
That was Dr. Johnson, but that's the first thing that Paul said to me, and I still remember it.
In your annual review.
Yes. The second thing, the corollary is,
Still here.
but we must hang together, or we will all hang separately for sure. So when I look at groups of 5 or 6 people, we're a group of 14 people, we're not going to make it against the big guys unless we knit it together with open source, have something that's more powerful. So a lot of this is sort of finding our lanes and spaces so we can all sell together. And what I hope is after more of these meetings, my customer can be your customer, can be your customer, can be your customer, because that's the only way we're going to beat the millions of Microsoft sales reps, the OpenAI momentum. It's just impossible, right? The second thing I want to talk about, though, is LLM commoditization. And essentially, if you don't need 1 million tokens, and this is the key, then there's a lot more commoditization. And there's such a resurgence from Gemini to Claude. China right now has 3 of the top 10 models, fully open sourced. So there's a lot of opportunities, and it is literally, ladies and gentlemen, raining 3 to 8 billion parameter models. Like our company can't keep up with the number of amazing 8 billion parameter models. Now, the big difference though is they are not general models. So for instance, out of UT Texas is probably the best fact checker I've ever seen called Bespoke, right? There's also another model called LM Markdown that is the most amazing JSON to Word Excel document model. There are no less than 2 models right now, Llama 3 Guard and Gemini something, which basically are prompt guards. So what you're seeing is a rapid dissolution of what is one gigantic model into all these pieces. That's really good for all of us, right? And that means why reading research papers is so important, because this is something researchers can do. And just to talk about research, since my son, full disclosure, is a postdoc about to become an assistant professor, none of the big research groups can compete with 30,000 H100s. So the largest research group complex I know is about 2,000 H100s, soon to be B200s. So what they're doing is they're chopping the problem up, doing specialized models. That's amazing for us. That means UT Austin is clearly becoming the fact checker, research group of the century. And you can ask it any question, and with a 99% thing, it'll say by the way, it only answers yes or no. So completely tuned, 8 billion parameters, actually beats GPT-4o in fact checking, runs on my laptop at 100 tokens per second. That is really good news for everyone here, right? Llama 3 Guard, excellent at this prompt. Hey, John. Right. This prompt is bad for you, right? So we can basically deconstruct things. The third thing I want to talk about is how we're now at the point where we're really hitting the wall. And I was talking to Brad Silverberg, whom some of us know, who's sort of Mr. Windows in the day, and he said every revolution eventually hits a wall, and it's the same wall for enterprises, right? So HTML, cloud, and so forth, and the wall has to do with, first, I can't get my people to move, and I shudder to think how London Stock Exchange is going to move their 3,000 developers to being AI oriented. The second is I don't want to get locked in. The third is need to be reliable. All the things that you need to make things work right. Steve is shaking his head because that is exactly the problem. And I think the prediction I'd like to make is companies that get past this enterprise wall, the ones that are going to win, right? Now, it turns out a small agent framework that's designed for enterprises is actually very well positioned to win, because small means reproducible, reliable, runs small. So our bet, and I'll just cut to the chase, is we're completely betting on local frameworks, mainly on small machines. That means, by the way, you have to design all your models to be small. Turns out it's very hard to shrink a 10,000 line prompt to a 4-line prompt. That's literally like, how do I take mainframe code and make it run on PC, which early part when I worked at Morgan Stanley, that's what we spent all our time on. And the answer is just stop, just rewrite the whole thing. Because if you have something that needs a 3070 or System 370, I don't know what they call them today. Is ES3090 still? I don't know what it is. But in ES3090, you're never getting it to run on a 4.77 megahertz 8088. So you start all over. So we're spending a lot of time on these. And I think these first, we call them safe applications, small agent frameworks for the enterprise, are really going to be the ones that can really win and be reliable. The fourth thing I want to talk about is a little bit about hardware, and it is sort of the tale of 3 cities. So B200s, which are just coming out, that is like the ultra premium luxury. I'm not going to go through the whole presentation, but essentially $1 million per GPU when you're all done, right? So a 10,000 GPU complex is somewhere in the $10 billion range, because you need 120 kilowatt cabinets, you need air or water cooling and so forth. But the thing people don't talk about is the absolute unbelievable price collapse in the mid-range. So H100s, for instance, which are now obsolete, the prices collapsed by almost 4x. And someone mentioned this, right? So today, for instance, by using a good framework, you can, most of our Llama 400B and Llama 70B compute is absolutely free, because people are giving away H100 access for free to try to get customers. So if you're smart and you can get your training to fit in an H100 class machine, training costs are basically going to go to zero, which is what we're doing. The other thing that's changed is essentially ARM has totally changed the dynamics on the low end. So we're actually moving most of our developers are only doing their compute and development on a local machine with local language models. Again, two reasons for that is if the developers write in the small, and this is another lesson from maybe Cutler, I don't remember who it was, from Microsoft, make them run on the machines that the customers use, and then you can make sure the software really runs. So we're forcing people to run on the low-class machine and trying to get these things working. The fifth point I want to make is, there's been a big industry change. It's been sort of silent. A year ago, OpenAI was clearly the technology leader. You looked at everything, they were the leader. It's actually changed quite a bit. I track OpenAI things, but you can almost always find an OpenAI analog now in the open source community or from somewhere else. So that technical leadership has changed. However, they remain very much the safe choice, right? So that's why everyone's using OpenAI, and it's become really a marketing machine. And there are certainly many groups here who are making a lot of money being an OpenAI reseller, et cetera, et cetera. So that's the sort of in the nutshell.
Rich, are you going to cover the difference between the LLM cost and the SLM cost?
Yes, I'm going to cover that right now. I can summarize it. SLM costs are essentially zero, and LLM costs are low, probably going 5 to 10x if you're in a locked-in system. So I think if you're doing this planning, for instance, it was so hilarious. OpenAI dropped their prices by 5x, on their latest model. Some people in this room might have advocated for zero cost. That's what I would do. Because I've got infinite money from Microsoft. Of course, you want to get everyone addicted to a zero cost million token thing, because remember, their model is based on tokens. And so the smaller the token cost, the more the lock-in. And there are some people in this room who've may worked on I have a lot of money and you don't. So the lower the price, the better. And so that's the thing that I think everyone needs to be aware of, is that today's token price is not tomorrow's token price. However, the price of a small large language model running on your system will be zero, because the marginal cost, and by the way, just to scale this, so Microsoft and Apple are all moving to 16 gigabyte standard ARM systems with 40 teraflops. Right, just think about that for a second. This will run small large language models at between 30 to 100 tokens per second without any problem, and can typically run 4 to 5 memory. So that means that most systems can scale there, and then there's no cost because you have to buy the laptop anyway. That's a $1,200 box. People are spending $1,200 anyway. The desktop only versions, which I think the Mac Mini will be the first one, that's going to be a $600 box running 16 gigabytes. And that is a revolution for everyone here. The second thing I wanted to say is there are so many layers to AI, you have to really scale on what you're talking about. And I sort of have a simple 4-layer framework. And every time I talk to someone about AI, I have to put them in a box because we're all talking different languages. So the first thing is, at the very top, there is, and these are the keywords I use to sort of detect what a customer is talking about. So first of all, there are AI enterprise solutions. And here's my keywords. If they utter the word Excel, I know they're talking about AI enterprise solutions, because almost all of these things are, I have an Excel spreadsheet and I wish I could do better. The second thing is they talk a lot about in-context learning. I'm not going to talk a lot about AI consumer applications, of which there are a million. I do want to say enterprise apps and consumer apps are very different for the simple reason that if your question about a recipe doesn't work, the debug is please ask again. Right, that does not work in an enterprise. I do think there'll be a lot of, and I was at Julian's, right? You can ask it questions about recipes. You can talk to it in real time. Clearly, a lot of the $20 per month going to $44 a month for OpenAI will be that form. And who cares if the recipe is wrong, right? It's a very low bar. Consumer apps I think, are that great. The other keyword is copilots. And I use so many of these applications that have a copilot, which, by the way, at least my experience, work like crap because they're just bolt-ons. And after 10 minutes, you never even use it again, but it's a great marketing tool. Then there's sort of the layers down. And, there's not a good term for this, but these guys over here are talking about, every time I hear the word notebook or Kates, you're in MLOps domain where people have experiments they're trying to run various pipelines and so forth. I think that's a huge area of investment and need because we run a lot of notebooks too, and the infrastructure is just terrible, right? And the problems that you can't see. Was it you who were talking about this? The problems of the notebook literally ran like last week and it no longer runs is real, right? We actually run our own Kate's infrastructure. We should probably talk to you because there's no other way to keep things simple. The next level is when people start talking about airflow and big data systems, then you're kind of in the world of foundation models and big data, and that's all about piping massive amounts of data around, typically not at the solutions level. I don't see that a lot in the solutions level. That's like, I really want to completely retrain a model for fraud analysis and so forth. So that's sort of my decoder ring of those things. And then you're down in the AI data center, which is the Samba Nova, the B200, what is ARM going to do? Those questions are much deeper, lower. So I will spend most of the time sort of at this top up here, mainly because I was deleting slides like crazy because I think the previous sessions covered the problems of notebook running and of foundations of big models super well, right? And just to summarize for those people who are on the Zoom, in essence, at the ML ops level, essentially, every time you try to make your notebook run, it doesn't run anymore. And then you've got to optimize your pipelines. I know of many companies, for instance, who stood up these pipelines and no one uses them, right? And so you end up in this mode where nobody can actually use it, and then suddenly you get all of this use. So actually managing these things, again, full disclosure, my son works for Meta, and that's all he does for a living. He's got 1,000 researchers, and he's just trying to manage the notebook pipeline. Just trying to get to the point where you get some reasonable utilization because they've got 7,000, I don't even know how many, 7,000 to 10,000 H100s, and they're trying to manage load. And no one, of course, wants to use their cluster. They want to have their own cluster. Someone mentioned, and I want it under my desk. And that is, by the way, the standard. Everyone just wants to run the cluster underneath on their desk. So with that being said, I'm going to spend probably 5 or 10 minutes, and apologies to Paul, talking about selling these products. Because everyone I talk to, how you sell it has actually become really hard because we're at the level of, I believe in it, but what do I do next? So I'm going to just show you how we present these things, and maybe we can all share and get there. And the first thing that I think is important is that this is really a revolution for most folks. I don't know how many people I talk to, they don't really know what AI is. If you're a CIO, how are you supposed to know? If you didn't get a degree in 2022, how are you supposed to know what training models and so forth? So we actually start with just trying to earn credibility at the beginning. And that's actually quite important because we all come across as breathless technophiles. Not me, of course, I'm very wise. So this was forced upon me by one of my favorite people, John McQueen. So just start at the beginning. Don't make this so mysterious. So, and I want to say, we do take Paul's name in vain here, and Harel and other people, because there are a lot of recipes for these changes that come from 30 years of working on things, right? And one of the good things about many of the people in this room is we have been through multiple transitions. So making sure you realize, these are basically some of the people.
The flaw with this, Rich, is it assumes that we learned something.
Well, they don't know that we didn't learn anything. But it's important, I think, whenever you're a small company, to remember that if you've been through one transition, that gives you a lot more credibility, right? And so the second thing, though, is what are the lessons learned? And this is one of the things we do go through a lot, which is what are the characteristics in a revolution that have to be true for this to be successful? And I actually do. I'm not going to go through the whole thing. Go through the big lessons through my career. And the first one is, of course, with the original PC revolution. And I always ask, how large was the Excel, which is today the dominant spreadsheet, how large was the development group on Excel? By the way, just to give you to just sort of size that, Lotus 123 was the dominant system. They had about 1,000 developers. IBM, I don't even know how many developers they had. They had 1 million. The total
Real developers.
Well, this is the problem, right? When you talk about big transitions, the actual core Excel development team was no more than 4 people. And actually, the entire recalc engine was run by a single person. So this is an era where when change happens, it shouldn't make people scared there's only 4 people in your company or 7 people in your company, because it's about the right 7 or 8 people. It's not the great masses of Microsoft consultants. And so unit quality, which is sort of an American military term, is actually the most important thing in revolutions. And every time I see these changes, I just think about, is this company got the best team? And not to cast aspersions after any large thing, but when you see luminaries in a company leaving, like Ilya from OpenAI, you really wonder what's going on, right? Because for those of us who are in the industry, we know Ilya basically invented decoder transformers and made the big bet, right? When Karpovsky, when Andre left Tesla, that was a big deal. You know, Karpathy, who's like one of the founders of the entire transformer model, leaves, you're wondering what's going on there. Because literally, just people probably don't know this, the entire thing that's running in a Tesla was written by Karpathy. In fact, it's buried in the code, right? Karpathy network, it's called the KNN, right? So you just have to realize unit quality is the most important thing. And Steve knows this well. It's not the millions of consultants, it's that one person. There are a lot of other things like trust, right? Like not screwing up. And Paul knows this very well, defense messaging, which is one of our first true applications for NT, server thing. The importance of making that really work well and never losing a message. That's how you develop trust. So these prototype people who then launch an app with a 75% reliability, that's the way to instant death. So we've been focused very much on, can we just get one application right? Because you learn a lot from getting one application right. Now, Steve Hooper, whom none of you know, but was the CEO of AT&T Wireless, which is one of the big mobile companies. You know, the whole thing started as phone as a portal was going to be the dream, right? And it's interesting that that whole thing, by the way, the thing that cracked the market was Citibank just doing a bank balance app for the first phones. So starting small is really important, right? Because no one back in 2006 was going to like transact on a phone. That was crazy. So bank balance was the first application. I was a venture capitalist at the time. We ended up selling a company for $300 million that all it did was bank balances, right? And as Steve will remember, that was very valuable because it reduced the number of people going to branches. It was a very simple app to understand. We sold it to FIS for a big number, and because that was a simple application. So I think the lesson here is you start small, you can win. Now, someone here mentioned open source. I think it was you. You know, I think the big lesson I learned between 2020, 2017, and none of you here know John Ludwig, but he's one of the most wonderful dev managers, and I worked with him for a long time, was just this whole open-close battle, in my mind, was decisively decided in the last decade, which is essentially, and the start was Git, right? Today, I just did our count. In our company, we have 246 repos, right? Because there's so much power to contributing to the open source community and then building on top of it. So all of the technology you'll see is actually fundamentally based on this. I admit I do contribute to open source projects regularly because now I'm no longer a marketing person. I can actually write code. But really, the point here is the hive mind is so powerful, right? In fact, just today, we're making the decision to change a bunch of our front end to an open source project that we think is better. We're going to contribute our pieces. So this balance between open source and closed source, that's really the magic. We retain control of our proprietary models, the things that are behind the firewall, but a lot of things are commodity. Why fight the tape, if you will? Now, the lesson I learned from 2015 when John and I first started our first AI company, Paul was, thank you very much, a backer doing computer vision, was in essence, the problem with AI is all of us are learning, right? No one knows the answer. So everyone's a teacher. And I think the start that we found is, ironically, a lot of people want a lot less Excel. It's kind of funny because Excel is like the glue of the industry. Like, how do I get less of it? And the problem, of course, is how do you make it reliable? So that's very important to sort of summarize. Now, the next thing, I'm not going to go through these slides, but we do, unfortunately, have to do slides that frame what is this Gen AI thing. There have been so many, and John, you sent me your article, right? And no one even knows what it is and what the impact is. And I think the world really, and I use this slide a lot, really oscillates between two things. It's either stochastic parrot uttering BS, and I shouldn't take it seriously. This is very characteristically people who have tried ChatGPT and it's failed, and they know it's not going to work, right? And then on the other side, you have, oh my God, there's going to be no more jobs. There's too much work to do, and artificial general intelligence is going to kill us all. You just never want to even think about it. Where we try to stay is, it's really about getting more growth for your business. It's about making better decisions faster, less Excel glue, and getting higher software productivity. I think, ladies and gentlemen, if we stay in that range, we'll be good, because that's the range where you can really operate and do things well. The number of senior CIOs and senior dev managers, they don't really even understand what a software weight matrix is unbelievable. So I actually normally take people through a very simple example of like how weighting works. And I can't believe how effective this is, because suddenly you gain the high ground of, because no one wants to admit they've not taken Karpathy's class in CS 229 from Stanford. Who's going to admit that? But really, when you talk about weights and hallucinations, unless we give a grounding, we're not going to make a lot of progress. So this is a very simple example. I apologize to all the real computer scientists here. This is not accurate. It's just meant to give you a sense for what it means. So up here you see, here's a plane, and down here there's a bird. Now actually, this is a real example, because my middle kid, who's now 27, 28, he's 28 now. I showed him a bird, and then there's a plane, and he goes, "Dad, there's a bird." And it's a 747 flying across. And actually, superficially, they look the same, right? Black against the thing, something in the air. And his basically net weight matrix was, he's never heard of a plane, so it's 100% a bird, right? Has to be, because everything that flies must be a bird. This is sort of the thing when people really don't understand what training is, right? So then if you feed it 1,000 examples of a bird in a plane, which is what airflow and all that stuff is doing, you end up at a point of maximum confusion. And that's actually where Calvin ended up. Well, I'm so freaking confused. And you end up with, this weight is, if I see this image, it's 50% a plane, 50% a bird. And you basically end up with, I'm confused, or what all kids do, which is, I'll just guess, which is, by the way, where a lot of hallucinations come from. So I had no freaking idea, I'll just guess, right? And the point is, these systems, and this is unlike any other computer system, it never really knows anything. Everything's probabilistic. So if you train it enough, even though, by the way, when ChatGPT says this is this and that, it's just picking weights. It's just picking the highest probability items. It has no idea whether it's a bird or a plane. And in fact, inside, we don't know how this happens, but this is 90% a plane, 10% a bird. This is 90%. There's only 10% a plane, 90% a bird. By the way, if you then show a kite that's a plane, you're back to square one, because you can actually buy kites that looks like planes. So we are constantly in the train-retrain model. And I can't tell you the number of people after, when I give this presentation in the keynote, they're like so grateful. Like, I finally understand why hallucinations happen, what happens in the system. The second thing I actually spend a lot of time on is, what the hell is this embedding vector thing anyway? You know, we in this business talk about tokens, we talk about embeddings, and I tell you, no one really understands what the heck we're talking about. So, for instance, when you talk about context buffers, which someone was talking about, it's like, why is it, and what is it doing, and why does it live there? And one of the key things most people don't understand is, when you type the word king in ChatGPT, it never sees K-I-N-G. Right? It doesn't see that. It sees an embedding vector. And, you know, this remarkable property that if you take the embedding vector for the word Paris and add it to the embedding vector for the word France and track the UK, you get the embedding vector for the word London. It's one of the most remarkable things that even today, after reading the paper, and this paper is now 11 years old, I still can't believe it. Right? And the intuition here, which is really important to understand these things, is that the word king is actually mapped to essentially a 1,000-dimensional vector, right? So the word king is not the word king. The word king has got all these things like royalty. It could be a boy or a girl or any gender. It could be this or that. And you can sort of see this illustrated here, where the word king, you know, the difference between man and woman in the word king is, king usually implies, for instance, over here, there's probably some embedding for the word the meaning of royalty. And so this probably means this is not it. These things are all human, so this is blue, right? A gender for a king is typically male, so that's why this light is light blue. So when you think about this embedding spectrum space, it's actually very important to understand fundamentally what's happening here. This also lets you do things like cosine similarity, which basically say if you have the word J in another person, you can basically run in this vector world, how close am I? Right? So just explaining to a CIO, that's actually what's going on. But it doesn't actually see the name Steve Suarez. It actually sees an embedding vector for Steve and Suarez. And yes, that embedding vector somewhere is very much tied to the embedding vector for HSBC. Because there's a lot of times when the word HSBC and Steve Suarez, and of course the embedding for the word famous and amazing are all correlated. We know this.
All right, how much money do you want there?
Yeah, no, that would be fine. Pre-sales. But and then most people don't understand even what a vector database is. You know, we throw these slang terms around. Suddenly a vector database makes complete sense, right? If you convert all these words into vectors, then you'd rather store those vectors instead of storing the word token. And now you can understand what a context buffer is up top. All it's doing is that translation from king to that zillion dimensional vector is really expensive, so you just cache it, right? So suddenly I think that we need as an industry to turn this amazing, magical stuff and stuff that a regular person who actually went to school with and that actually learned C can actually understand what's going on. And I don't mean to lecture to you, so please feel free to ask questions as we go. So questions? No questions. That's either bad or good. Never really sure. So that is sort of my contribution to the collective, how to talk about products. Amazingly, when we do our presentations, we probably spend, I don't know, Simon, half our time doing this just to get to the point you get some credibility. And Steve, you can probably opine, a lot better than getting filled with a bushel of facts, right? You know, I just got a presentation on quantum, for instance, as Steve knows, and the guy just like immediately launches into logical qubits, right? And of course, he's into it. Like, what is a quantum? I don't even know what it's for. So my biggest advice to everybody here is you're going to have 3 or 4 slides. Just be, number one, someone who's been through the revolution, and be somebody who has some insights that can get people on your side of the table. By the way, we did this, our success rate on this presentation is now 110%. So normally when we do this, we usually get the partner, someone else, and the third person saying, oh my God, this is so helpful. Can you present to us? Right? Because that's what we all want to be. We want to be the point of information mage, because the information flow is very poor between the information here and what's out there. Okay, second thing, and unfortunately, Yoshio Bengio did not win a Nobel Prize, but he did win a Turing Award for everyone you want to know. That is in some ways more important, and I don't really know how Hinton won it for physics, but we'll leave that all aside for dinner.
You didn't schmick a bit.
The deep mind guys, that made total sense to me. This idea that embedding vectors are the key to human knowledge, I find that this is a good way to get the discussion going, because when you start thinking about what the implications of these embedding vectors are, it's very likely the word plane, for instance, has a lot of meanings. Like the first time I got on a 707, what it means, I'm worried about crashing. You think about the number of attributes when I utter the word plane or Steve Suarez or Paul Moritz that comes up. That is, Bengio has speculated that is actually how we store things. That's why there's no word K-I-N-G. There's no word that is your name. The facts about you, for instance, I think about John. Met him in London, super smart guy, document him, great startup person, amazingly smart. Those are all embedded in my embedding vector.
Yeah, so what about knowledge graphs?
Well, this is the important thing. Knowledge graphs are a way to tie these embedding vectors together, right? So, for instance, John and Steve met in London. This is the knowledge graph. The point of knowledge graphs is to pull those embedding vectors together. Because right now, the naive ways, you have to find John Newton next to the word Steve Suarez in enough documents. But if the knowledge graph hints, these are all famous entrepreneurs in London, now I've pulled it together without having to have it in the document. That's also the reason embedding vectors are so important. That's the reason these basically encoding the relationships is really important, because what it's doing is pulling the vectors together. And I have to tell you, every time I think about this, I just think about, John's vector was over here, Steve's vector was over here, and Paul's vector is over here. The knowledge graph says they're all AI hub people. And so remember, I've got 1,500 dimensions. So I got plenty of dimensionality. So I can just pick a new vector. And by the way, no one knows actually how this happens. Don't think of it as one vector for each one. No one knows what's going on. But theoretically, what the knowledge graph is doing is pulled, on some dimension, Steve and John and Paul together. So that's why knowledge graphs are so important, because it's a way to give it even more hints than lexical distance.
Yeah, I like Ilya Sutskever's description of what's happening here as it's a compression of knowledge.
Yeah.
And then coding and compression of knowledge into its small, ultimately into its smallest.
I think Yashio would say it's actually an expansion of knowledge. No, but I mean, you're right, it's a compression of knowledge, and then you have all these attributes. But if you just pick the name London, think about the number of things. You had 1,500 dimensions. Think about the number of things you could use to describe it. Right? So in a funny way, this 1,500 vector thing is an amazing way to compress the knowledge across 1,500 attributes. Right? And before, the old system was London. Okay, let's do a semantic graph. Okay, London, colon, capital, this and that. And this is all doing it for us automatically. And in many ways, the large language models doing this are even more amazingly than the actual output. One hint to those of us doing enterprise applications, re-encoding the tokens is actually kind of an interesting idea, right? Because the lexical distance for things in the London Stock Exchange can be quite different than in the general corpus.
The compression also is very directly relevant in the actual algorithm for how the embeddings are produced in the first place, which is essentially matrix completion.
Yeah.
You're representing all these embeddings in a very, very sparse model, which is vectors for every word, such that if you take the combination of two words, you can produce a gigantic matrix that gives their similarities.
Yeah.
That's how recommendation systems are done.
That's the core recommendations.
Constantly, so you can always do a lookup of what's the affinity for this user for this product, and it's a matrix you could never represent in memory.
Last thing I want to say is I often give a quiz at the end. So this is another little demo trick, and I say, okay, if you got this Python, this is by Paul. If you got this Python program, why does write as hip hop actually work? Right, and so the program is A is greater than 2, B is equal to 2, and I just prompted write as hip hop, and you get if A be greater than 2, I can't rap. Said B equal to 2, that's what we do, and suddenly this becomes very clear. When you see Python A is greater than 2. All those embedding vectors that have to do with programming come before. As soon as you utter the word hip hop, the word choices change immediately, right? Because hip hop uses greater than 2. That's what we do a lot, right? So this is not magic. This is just we're bringing together these vectors in a way that makes the word "that's what we do" be much more highly likely, and it's got to express that A is greater than 2 as well. So just this instinct on how this works, and that as Shakespeare, much less mysterious. How many times do you think the word Shakespeare and the word heart are lexically close? Like all the time, right? How many times is the word forsooth there? Paul actually asked, does it know Algol 68? And actually knows Algol 68. By the way, I had to verify this actually is true. But Algol 68 is tightly tied to the syntax, right? As Lisp, my first and favorite language, this is also lexically correct, but SecQ is very closely tied to the word Lisp. And of course, Lincoln, in America, 7 years ago. So suddenly it's really clear how it's doing these associations. Okay, well, that was the end of the announcement on how to sell. Let's get down into the dungeons. The second thing we talked about was really how it's really raining LLMs. Now, I've done a number of charts where I take the comparison, I take the top ones, and I say, which ones are closest to ChatGPT?
I just want to remind you, you're now 1 hour in on a 45-minute presentation.
You gave me 2 hours.
That's why I did it.
That's why.
I expanded it to 2 hours.
I can see the next time it's going to be 5 hours.
Keep going, it was great.
Yeah, so just so you know, I walked in last night, I think it was a 45-minute presentation. Julian told me it was 2 hours, so I added the entire enterprise selling part. I added all these things, and I'm like, oh my God, I've got to add more content.
Doing some knowledge expansion.
No, I had the knowledge expand. Okay, so on the It's Raining LLMs thing, I've done this thing ever since ChatGPT came out, comparing the models. And just so you know, there's something called LMSys, random reviews. People type random things in, runs it on a chess score. Just so you know, the chess score thing is if you're within 100 points, on the chess score thing, it's a 60-40 win rate. So if you had 1,300 points versus 1,200, it doesn't mean the 1,200 guy's going to lose all the time. It just means he doesn't win as much. So here's the bad news. I went through the entire LMSys thing. Turns out every model is within range of ChatGPT. So ChatGPT is at 1,300, the lowest model is at 1,230. That means all of these models are essentially equivalent. So this, by the way, personally, I thought ChatGPT would be much more ahead because they had such a lead, but it just goes to show how much work is going on. I'm going to share these slides, but you're going to see Gemini up there a lot, right? You're going to see a lot of models that you've never heard of before. I'll give you one example that I'm Claude Sonnet you've heard of. We've heard of Meta, but who's heard of Ye Lightning Light? Hey, who's heard of Ye Light? Does anyone even know where it comes from? It's a Chinese open source model, right? So you're talking about models that are not even in that.
Are the Chinese source models open source or open weight or both?
It varies. These are actually open weight. Right.
They're not based on Llama 3.1 or Llama 3.
Yeah,
Sorry, we couldn't quite.
They're based on Llama.
Yeah, so they're based on Llama.
Llama, okay.
Chinese have a huge issue of getting GPUs at the moment. The policy. So a lot is based on what Mistral open sourced and Llama open sourced. By the way, but huge issue with these comparisons is that the data, the evals of
I don't know if the people online can hear you, so maybe you can just move closer and yell.
a huge issue that potentially causes this is that the evals, so what's used to evaluate the models, is contaminated. So many of them are based on open source stuff, able to do a lot of the evaluations. And as an outcome, many are actually including the evaluations in the training.
Oh, I can't imagine. Why would they do that?
But that causes this collapse, right? Because you do see like a difference in actual performance across many use cases.
That's why, by the way, I like using this benchmark because it's random humans typing and it's much harder to capture. But you're right, every benchmark is
Problem with LLM is that they find a way to ace the evals.
clear that there are prompts somewhere that says, if this benchmark is this, then answer this. You can, not that like I would have ever cooked a benchmark.
But you claim that these are not susceptible.
These are less susceptible because random people type in random queries and they compare the two and they decide whether one is better than two.
The issue is repetition, right? Just because, you would expect like a distribution that would be the entirety of the world, but most people tend to ask very repetitive questions. And as an outcome, since many of them are also replicated into benchmarks that are based on natural questions that people ask, now these benchmarks are part of the training sets, which causes like
benchmarks.
Essentially, even accidentally, just because many of them are open sourced.
But I think that, I guess the point I'd make is that today we can have these discussions because the models are rapidly converging and they've learned the entire internet. And you can actually do these, and I've done these evaluations myself with strange questions, and they are really capturing most of the standard questions you want to ask. But what it means is that everyone here has a lot more choice because some of these models are totally open source.
Right? So just to your point, Dan, are you saying that there's a evaluation matrix that should exist, which would show more meaningful performance differences, or is it, as Rich is saying, everything is converging?
So I think for some use cases, you're naturally going to see a convergence. Just because there is, even if you're cooking the evals, then essentially, if the evals is, your benchmark is the entirety of the universe. Even if you're studying that, but you've studied the entirety of the universe, then you're okay. I think the separation may be more interesting across applications that may not be ones or ones that are going to be more presented on the internet, and then they're going to see something which is a bit more. It's kind of like in classic LMs or classic actually ML models, where you see models that are very close, but actually when you're doing just like some small changes for separations, for example, just like doing things squared, then suddenly see like a way to differentiate more. Novel use cases or just like models that are more aggressive across like some applications, then you're seeing actually like some performance boost.
I totally agree with you. One of the ways to think about it is the internet has this bell curve distribution of questions, but that is not the same curve as, say, in London Stock Exchange or for this or that. But the point I wanted to make is that a year ago, this was not even true, right? That most of these models couldn't answer the internet's questions very well, and there's been widespread convergence. And it's interesting, the model sizes have been shrinking too. So we think that GPT-4 was a 1.2 trillion parameter model. There's some belief that GPT-4 mini is somewhere in the 70 billion parameter. So there's both been a shrink in terms of capturing all questions on the internet. There's been a huge shrink, and there's been a commoditization. Right. Rich, can we?
I have a quick question here. This is Wasif. I'm sorry, I don't know the speaker's name on the left who was talking about the benchmark. Is there a better way to benchmark these models that you're aware of today?
Yeah, so for example, you can do stuff like having private benchmarks that are not going to be published online, and that you're going to like send the models for the people that hold the benchmarks. And as an outcome there, you're presumably going to see more separation across some use cases. For example, we do know that different models perform differently on use cases of things in like deep biological research, just because that's not like something that's like very common online. Of course, like some niche use cases in bio, and if you hold some of the information from the models, then you're going to see like a bit more of a separation between them. So that would be like one technique, which would just like have holdout sets that are not online to avoid these kinds of issues.
I agree.
Which benchmark was this?
It's called LMSys, lmsys.org. And I agree with you. I think the real action item is you have to look at the use case and create a data set that is actually interesting and then test it against that application. And this is also where you end up with a model that may not even be on this list is better. Yeah, right. So for instance, Bespoke, which is the fact check model, does not appear here, but it's amazing at fact checking.
Rich, can we just loiter for a moment on the question of openness that Paul touched on a few minutes back? So, we've got open models, we've got open weights, and there's a push from the open source community for open training data. OSI at the moment seems to be trying to ram through an OSI approved terminology that would not require that. But there's a lot of kickback from the four freedoms respecting part of the community. Where are things headed with that?
Okay, so this is a guess, but I think, my personal view, Meta being this open has caused a huge innovation. So right now, Hugging Face is over 1 million models that are essentially almost all based on Meta in some ways. And I think there's sort of a good...
To clarify, Meta is open weight, but not open source. Is that correct?
No, Meta's open.
Is it truly open source?
Yeah, truly. It's only limited to the
training data, isn't
it? The training data is not, okay.
But the one of the things you learn, just to cover that, you learn rapidly is the training data seems to be converging rapidly because everyone's
scanned the whole internet.
Everyone scanned the whole internet.
That's the pre-training data. That's not the post-training data.
Say again?
So convergence.
Come closer so we can all hear. Sorry, you should get a seat at the table. Yeah. Let's find a seat for you. Here's a seat here.
By the way, but this is Dan Lahab from Labs, who do all sorts of funky stuff with Frontier Labs. So
there's huge convergence around the pre-training data, just because that's the entirety of the internet. A lot of the innovation now is happening on the post-training data, right? Because what you can do is that even after the fact, after you've trained the model, you can have a dedicated set to do some tuning over it. That is highly proprietary. That's like part of the secret sauce of many of the labs, how they do it, which kind of approaches are used, what's included in it. because it's also a much smaller data set, which they usually buy from like some suppliers and have like play with that. The pre-trading data is essentially open benchmarks, the entirety of the internet, etc. And here there's huge convergence on like
He's my best friend. I totally agree with you. You want to do the rest of this? It's much simpler for me.
Well, next time he will prepare 2-hour deck. But do you see, you don't see any convergence in the fine-tuned data?
So that's essentially what's used later. And that's part that's also much harder to measure, just because it's proprietary and closed and much smaller.
And it's also come in chunks of expertise.
Yes, and many times they're buying it off like specific vendors that like filter that. A lot of it is used for validation as well. It's like much harder to see. And now there's actually like an emerging pattern of mid-training data. It's like stuff that they're using in order to calibrate the models during the process and not just like pre the process, which is like also like a question on exactly what happens there. Yeah, but a lot of the convergence is in the early part, because then you're just like taking like a huge thing.
Just like converging to the bottom, which is the whole internet.
Yeah.
Post-training is also more art than science right now. Like at Anthropic, there are a bunch of teams that come up with the post-training gauntlets, right? They're using their own knowledge of how the model needs to perform in different use cases to produce training data that will ultimately be joined together into a final post-training sequence when they release the big model. And there is one guy that, before the release, takes these dozens of post-training gauntlets and figures out in which order to apply them and which ones get in. And he cannot explain exactly how he does it. So it's pre-training is somewhat commoditized at this point. Obviously, if you talk to Mistral or Llama, they wouldn't tell you that it's still quite a bit that goes into it. But even post-training, it's not an exact science.
And I guess I'd say, Meta right now represents you. I don't think you probably disagree. Sort of good enough openness, because people can innovate on top of it. They can build new models on top of it. They can do adapters to it. They can do the training. The Chinese are doing it. Everyone's doing it. And so there is this sort of not truly open, but it's just good enough. So people just move on. And we're seeing a lot of that. People are just taking the existing models, doing their own fine tuning on it, and then shipping it because you can do it so quickly.
Which also explains the convergence in results.
Absolutely.
Like, because if you're using many of the same models and just like changing them per application, or just like fine tuning them, or just like changing it, you're just like playing with the bits, then
we have not yet seen. I cut the part about Samba and Mamba. That there's a bunch of completely different transformer models that should be better. Transformer should be better, but they're sort of not better. But last time I talked about the incredible refinement of these large language models, and that's really what's happening. I did want to get to the $10 million question, which someone mentioned here. You have to use Claude and OpenAI. The question is, when do you have to use these models? It has a lot to do with how big the prompt is and how much data you've got. If you can break things down smaller, things get a lot better. And I literally think for a lot of companies, it's like a $10 million a year question. Right? Are you locked into only using the biggest models? That's a big issue. So I wanted to cover a little bit because last time everyone was talking about open, and this time I feel like everyone is yelling the word agent, like in the room, like it means 100 different things. And I kind of wanted to break it down a little bit so people understand what agents are really about. And it's like all computer science, it's at the same time very mysterious and ridiculously simple at the same time. So I just want to explain the problem. I'm not even going to try to zoom this. This is a real application was deployed by one of our partners, and this is the prompts they use, right? So this is using LangChain, GPT, and I'll just read some of this for you. First of all, everyone mentioned LangChain. There's a mountain of SQL. A mountain of Python code here, and essentially all it's doing when you're all done is it's encoding a text file. That's it. Right? And here's what it says. It is extremely important that you always encapsulate the column names with square brackets instead of sales used. It is extremely important that you also encapsulate the auxiliary column names you create with square brackets. Whenever a query involves a specific category, blah, 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 blah. Right? So this thing is actually almost 5,000 lines of prompting. Now, we've already talked about, for those of us who are not in this every day, you can think of this as a gigantic vector. How important do you think the token it is to the actual answer?
Isolation of its part of it is extremely important.
And what part of duplicating it is extremely important twice is there? If you think about this entire thing summing to some gigantic vector, does that really matter? Make sure the columns used in calculations or operations are of appropriate data type. How important do you think make sure is actually changing this thing, right? Now, it turns out, and this guy tried this, shrinking this prompt down, oh my God, it's impossible. And you can apply DSPy, you can apply all these things, but essentially, there's a lot of noise in this data, right? And one of the famous things about the more data you have, the more you don't know what to compress, right? So a lot of these DSPy is an optimization thing. They end up actually just encoding all the idiosyncrasies of the data set. So this is the problem that people are facing. And by the way, this thing no longer works with LangChain v2. So there's the other problem. There's new pip packages. It no longer works. The guy has to go figure out what's wrong with it. But essentially, there's no work in here, right? It's just it's a text file. So the challenge is, by the way, I just want to say, it turns out you can place all that. And we start with a small language model with, in essence, 20 words, right? Turns out that whole thing can be replaced by, say, step by step. And now, why does this work? As soon as you do step by step, the LLM is like, I'm thinking about steps. If you say the word check math, it starts to check math. And then if you just say analyze sales, it doesn't need all that stuff because it knows a lot about sales. So one of the funny things about these large language models is many times fewer tokens are actually better. I just wanted to give you a little intuition. You can explain it. By the way, I want to apologize. This is not technically accurate, but it's just a conceptual thing. One of the ways to think about it is a large language model, and there has been research to show this, it's got all kinds of little networks inside of it, right? So when you get a prompt, it's got a CNN, which is for images. It's got an RNN for text. It's got an abstract symbol table. And what's happening is you can think of, if I put the prompt the word inventory, it's literally like shutting down the activations. It's actually shutting down the network. Because if you say the word inventory, the likelihood that my next question is going to be, tell me about Taylor Swift, is really low. Right? And remember, these large language models have encoded in it quantum physics. See, right? Quantum physics is right there. It's got everything about every media candidate. So the intuition here is the fewer number of words you use also means you can actually have a much smaller model because you don't have to wake the whole thing up. And that's why if you use small prompts, many times it'll actually run better in a smaller model, which I'm going to show you in a second. The other thing to understand is, again, by looking at activations, it's also been shown that different modalities all lead to the same activations. So the word spider, a picture of a spider, the word Spider-Man, and actually the movie Spider-Man, and these models all end up in the same node, which is this thing that means spider. So what you're learning is that some of these rules can be highly abstracted. And if you just want an inventory model, you can cut away all the bits inside Llama 400B that talk about Taylor Swift. And so when I think about doing these prompts, just in context, obviously there's a lot of other things you can do. The words you use actually sort of center the thing very quickly. Questions about that?
Yeah, what are you quoting from Anna Karenina?
What's that?
Happy LLMs are alike.
All happy LLMs are alike. And all unhappy LLMs are unhappy in their own special way. I always want to call it, I never get it, it's Anna Karenina, so I had to put Anna Karenina in there because I always wanted to be, just Tolstoy's name. That is accurate, I looked at it. Okay, so now what I'd like to show you is some of the stuff working just on I'm going to go through, let me just go through the problem quickly. So almost all the agent systems you see today are fundamentally based against the same cloud system, right? It's basically reprompting ChatGPT. And I went to Awesome Chat Prompt, which is the #1 chat thing. This is how you say, the CEO, I want to act as a chief executive officer for a hypothetical company, blah, 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 blah. Who here thinks you need all these words to act like a CEO? As soon as you utter the word CEO, like all the parts about CEOs immediately come into fore. So most of these prompting systems, including LangChains, essentially are just reprompting. It's saying, I want to act as a CEO, as a chief executive officer. You put all that stuff in, you feed it in essence, shut off all the parts of the network that's about quantum physics, and then you run it again. I want to act as a salesperson. You shut off all the parts about a salesperson. I want to act as a front-end developer. And to give you a sense of the cost of doing this, and I just picked Llama 3.1 because no one knows what OpenAI cost, but Llama 3.1, 405B, 128 context, recommendation is 600 to 1.2 gigabytes of VRAM. You need 8 to 16 H100s. It's about $1 to $4 million in data set cost, and it's about $280,000 to $1 million of hosting per year. Only, and just remember, it's mainly shutting off 90% of the network just to run a little piece, right? So, for instance, in all these little prompts, it never uses anything about quantum physics or Taylor Swift. It's all sitting there with zero activations. So this is the insight that I think the industry will come to, which is we need to differentiate between big agents and small agents, because small agents work quite differently. So in a small agent, and I just showed you this, our sales agent, by the way, step-by-step, this is the exact agent. Use, markdown, check math, ending inventory, analyze sales. That is actually our sales agent, right? It's 20 times smaller. Turns out this model fits well in a 16 gigabyte model. One of the implications, though, just to show you how the system works is, so there's a planning agent that has to decide things, run these things and try, but turns out for the CEO piece, we typically use Gemma 28B because it's actually quite performant. And most of the time when we want something to be deterministic, we actually just generate code, because code is actually the most deterministic thing. Typically, when you're trying to filter data, this is the easy trick, right? Because code is code. And by the way, for those of us who are computer science people, I can debug code, right? So this is typically only run once or twice, right? And then you cache the code. So, and then the second trick you can run is, if you have something that's a prompt, you can actually run an adapter, because if this is this small, you can actually adapt a very small amount of memory, create a LoRa adapter that adapts to Llama. So now suddenly you can actually load this and this together, and you've got a very fast system. It doesn't have to do token ingestion. It doesn't have to do any of that work. It's just running these two things together as a model. And then you can have a soft prompt, right? It says sales step-by-step ending inventory, and the developer can also be a 200 megabyte adapter. So you've actually shrunk the data requirement, the storage requirements dramatically. The second thing that happens is, because you have an agent system, you can now use specialized models for just what they're good for. So we talked about Reader LLM, which we use for JSON, the markdown text conversion. We talk about Bespoke for checking. So these are very high performance models that can run in the background. It does mean you have to have a scheduler here. Right? So one of the tricks here is most of the agent models just run 1, then 2, then 3. You have to be much smarter about the scheduling. Right? So you have to be in a mode where this runs in the background, because the checking can run async, and then this returns. So the idea of a directed action graph, a directed acyclic graph, and having this kind of scheduling is actually very important when you're trying to run in these small systems, because you don't want the whole thing to be blocked on the fact check. You want this to come up as an interrupt. And so this, by the way, looks a lot more like a classic web application. Right? So in fact, the technology we're using, which is open source, actually uses the Node scheduler to actually schedule things. And one of the implications for that, for those who are technical, is I can schedule code in the same way that I can schedule a large language model. So that's one of the key ideas here, is to try to get that to work small. And now the reason for doing that is pretty simple. You compare these two implementations. So this is a large cloud system. You've got it fully running. You've got $8 to $16 million of fully loaded cost. You're paying your network buffer cost. You do have a prompt cache, so at least you can save some money on tokenization. And this is actually a classic HTML1 for those of us who are old enough. Yeah, it's completely thin here, right? Like the Python code is literally post and then wait, post and wait. This system works a lot more like HTML5, which we have today, which is you can have a 16 gigabyte machine, you can run 4 3 to 8 gigabyte small large language models, and you can actually serve 95% of it locally, right? You can also have 8 gigabyte phones running 4 gigabyte small LLMs, and maybe you have a 90% serve, right? So this is a classic cascade. And then you can buy a commodity PC server. This, by the way, costs $20,000. Right? This is not even the electricity bill of this thing. And you can put it 64 gigabytes of VRAM, you can run 70 to 120 byte LLMs, and it's about $20,000. And yes, 0.1% of the time you can call out to this thing. So this is a classic design of a layered architecture where mainly you're running here, sometimes you run here, and that, yes, there will be times you may have to run all the way out here, but you're not sort of condemned to whatever this is. And by the way, from a lock-in point of view, this is very nice. Steve can tell us. Scaling here is really great. Just buy 100 more laptops for Singapore, and you're scaled, right? So this is part of what we think is going to happen is when people are designing real systems, you want it to work this way. Okay, Paul, do I have time for a demo?
Yeah, absolutely do.
Is the fundamental assumption here that you must run this on your own hardware?
Well, there's two things. You don't have to run it on your own hardware, but if you can, that gives you a lot more flexibility. So I always talk about this when I was an IT person. This is leverage against the cloud providers. Because you can always say, well, okay, if you're charging $4 million, I'm just going to deploy this thing and then you're out of the business. So it's a kind of a...
But I think the point is the point that Rich is trying to make is it doesn't have to be your own physical hardware, be your own virtual hardware.
Yeah.
So, those clients there could very well just be instances in the Amazon cloud or the Azure cloud or whatever it is. But the point is you're avoiding that call out to the thing that has, terabytes of everything associated with it.
And there's data that you don't want out there, that you got your crown jewels and you don't want anybody.
So it could be your physical private cloud, or it could be your virtual private cloud.
So for those of you who haven't seen this before, I'm actually going to do a little demo on my machine since I got 2 hours instead of 45 minutes. So here's one way. It is amazingly hard to look over here and try to make this thing work. I will try my best. So basically, there's a bunch of technologies for running locally. We use something called Ollama, which is open source. And what it does is, can someone see? I can't see well enough. Oh, yeah, here it is. So this is Ollama, and it basically has a collection of models that can be, for those who are technical, you can just pull the model down like you do Git. So what this is, these are, by the way, this was just shipped by IBM 8 hours ago. There's a new Granite model, right? There's Nemotron. A Shield Gemma is actually a very good model for prompt protection. Llama Guard is the other one, Llama 3.2. So all these models are available. And the way it works is you just load it to the cloud, load it to your local machine with a pull. So you can actually literally say, Llama run, and it'll just run the model, right? Now, the interesting thing is we're using, find this. Yes, there it is. So the open source community has actually gone ahead and emulated the entire ChatGPT interface, right? So this is actually, this looks like ChatGPT, but it's actually running locally. So for instance, if you look down here, you can run ChatGPT if you want, but there's also Llama available. Let's take a look at it. Llama 3.2. So, my favorite query, who is Taylor Swift? So now it's going to load the model in. Runs pretty good. So this is sort of the good enough piece of it, right? So if you just read this, it's just generating 75 tokens per second, right? Just so you know, ChatGPT, the full ChatGPT runs at about 25 tokens per second. And so this kind of thing is, if you can get and just your thing about the corpus and so forth, if you can get this thing to work for you, it can be very effective. So let me just give you an example of that. One of the things is you can do quite a lot of benchmarking, so you can actually add a different model and compare it. So I can run ChatGPT latest. Again, this is Gemma 2. This is the model that is open source from Google. Right? It's a 8 billion parameter model. So again, you can say. So this is a full Taste test. All right, so Gem's going to take a little time to load, and then it's going to rapidly catch up. So that latency was actually loading the 8 billion parameter model in, but you can see it's just about done. So the key question is, can you get this thing to fit, right? If you can get your models to fit in this world, suddenly you're in much better shape. So just to demonstrate a piece of that. So I'm actually going to run the prompt. So I'm taking this apart because it's all embedded in the system. I just want to show you in real time. So step by step. And I'm just going to put in a little database here. Now, why does this work? It's because when you say, as soon as you say check math, it's thinking about math. As soon as you say step by step, it's thinking about step by step. As soon as the word product, the whole thing basically tunes toward. So I'm not normally thought we put in a database, et cetera, et cetera. And I should have copied this first, but I'll simulate this. Let's have gloves, which are terribly selling. So there's an inventory of 800. They sold 2, and they shipped 400. And amazingly, you can say things like ending inventory. You don't need all that text. You just say ending inventory, question mark. Right? And you can say analyze sales. So what you're taking advantage of is the fact this thing has ingested the internet and knows a lot more about it. Just hit enter and see what happens. So it goes through and actually does the analysis. By the way, the reason this is fast is it's already loaded in memory. So it's high latency, so it's low latency. It actually goes through an analysis. Now, I'm not going to take you through all of it, but these are the techniques that teach you whether you can use a small model. So what we've been doing is building these little pieces that work like this. And then you can, of course, run taste tests, just to pick on that for a second. So you can actually compare them quickly. Now, we actually run this many times as in our own, I'm going to show you this in a second, in our studio. But you can rerun this, and then you can compare the two. Just rerun the whole thing. So that's going to run the Llama 2 model, and you can just check how well it's doing. It's actually the same, right? So,
is there any way you can swap the 2 screens there? Because it's easier to see the one to the left.
This is beyond my technical acumen. Does anyone know how to swap the screens?
There's always the small risk that you lose both screens.
Exactly. I think it's easier if you move.
John, I'm willing to try, but it might be easy just for you to move that chair there.
Just have this whole line of people right in front of me here. Blocking everybody behind me.
Okay. Last thing I want to show you is.
So which system is this you're using to do this demo? What's the runtime?
Okay, so the runtime is something. Just to explain the whole stack, if I should have done a slide for it. So there is a tool called Ollama that creates a server that can serve anything from the Hugging Face model pool. And then this application is an open source project that gives a user interface to it. And then what we've done is our studio is based on this, so we can actually do editing and work that all runs locally. So
did you add the local execution?
Yeah. So local execution is, so since we last talked, we were all cloud-based and we've moved to local execution.
So you're pulling out like a 3B or a 7B model from.
Now, remember, we can always still run the big models if we want, but essentially we're moving all of our studio and all of our execution as much local as possible. So we call it local first. So we basically make the thing work for local first before we make it work for cloud. And what that forces people to do is think about lots more small agents, which is exactly what you want. Because if you think about this, if you're just reprompting Llama 3B, 3.23B, you're only taking 3 gigabytes of main memory, and the prompting is very, very fast.
What about if you run like 10 agents in parallel, what about the context switch? Upload, download.
So the key thing is, if we run 10 of Llama 3, we're very fast because it's always in memory. So the trick is you want to load, what we do is we load a collection of models. We have, just so you know, today we're loading Gemma 9B, it's quite good. We're loading Llama 3B, and then we have Bespoke. So basically, it's like the classic physical memory map. You load up the models you think you need at the beginning, and then you use soft prompting for the rest. Or we load a LoRa adapter, because LoRa adapters are only 200 megabytes. They load very fast. So you can get the effect of 15 or 16 agents if you're careful about it without any swapping.
They're all preloaded.
They're all preloaded. There's no swapping. And that's how we get this performance, right? Because with these new ARM systems, as soon as you get in memory, the thing is just unbelievably fast. Almost all the latencies on load. Any questions about that?
Just out of curiosity, what model are you using for SQL generation?
We use a specialized model called SQL Check 4, something like that.
But you have a specialized model.
Yeah, what we do a lot of is we go to Hugging Face, we curate the thing you said, which is we test it against our queries and see which is better. And almost always there's like an 8 billion parameter model that works well. It's typically, as you said, a fine tune against Llama is the usual case. And they usually perform at the same level as GPT-4. Right. So I kind of think that, Paul, is I think most of the time Llama 3.2, 3B will be our base because good enough for these things. And then we'll move to Gemma. You can actually run a Gemma 22B quite efficiently as well in a 16 gigabyte system.
Hey, Rich, I'm going to put my banking hat back on.
Yeah.
Tell me the business model and how you're making money.
Okay. So the business model we have is first, we are working with our partners to essentially do proprietary AI models and reselling those. That's, I think, important to it because the behind the firewall stuff is where all the value is. So that's the first thing. The second thing is we do have a small charge for having the runtime and doing the scheduling and so forth. But believe me, our view is this: all the data behind the firewall is where the money is.
Right.
So our business model is to go to various partners who are in special areas where they don't have the AI expertise, but we do. And then in many of these industries, as you know, Steve, you can just get to small enough industry like retail, it becomes a standard model. Because we want to become that safe choice quickly. Because in many cases, people are still messing with foundation models, but there's no standard model, for instance, retail sales optimization. And so that's the goal, is to have a lot of these agents that are completely custom. And then we share revenue with the ISP.
It's a big investment for both companies to develop their own proprietary small model, like
Yes.
specialized, and then they can build on top of that incrementally.
Correct. You want to join the company? That's perfect information. What are you doing later?
Steve, it's similar to the Quantly model, which you start with a semi-consultative sale, typically done, except in their case, they find a partner who's going to do the consultative sale. So they're looking for vertical partners who can initially do the consultative sale, which will then pull through a standard product behind that.
And the reason this works is, just talk about our model a little bit. Everyone here is smart about AI, but the average ISV is struggling with the same problem. You know, they have 100 developers. No one knows anything about AI. Half of them are front-end developers. They need to get a product out quickly. So our mission is to go to these vertical and say, this is an easy solution for you. And as I said, hopefully also sell your product and everything in, so they have a nice stack, and then end up with a proprietary model we share revenue.
Ask what might be a very ignorant question from somebody who doesn't know AI so well, but running these things on these smaller hardware platforms with a little less memory CPU, what does that do to the scale of data you can pull in, you know, sort of in the way that you know, so obviously if it's linear, then fine, you know, it's linear, but is it linear, or do you get overhead in pulling this stuff in?
I'm so glad you asked that, because this is probably our biggest trick, which is typically, you know, basically the default answer to a big model is you just pour the entire database into the model, right? We're finding for many applications is just like humans don't read a million records, they want a summary. What we do is we use Gemma to create a Python program that does the summarization that's actually useful for humans, and that fits in a small model, right? Because actually most humans cannot ingest a million rows. What they want is the summarization. So a lot of the work that we do with the ISVs is, what is the summarization you want? And then you use Python or Rust, actually we don't even care what it is, to then process it into the summarizations, and then we operate on it.
That box you saw in the original diagram there was coming, where you said they use code.
Yeah.
So they generate code that will then query the database and get the condensed subset they need, which their AI system can then work with.
Yeah.
So they obviate the need to pull all 100 terabytes of data onto the laptop.
One of my jobs is, most people say, Paul, oh, I've got 1 million token context, let me use it. It's like the first instinct of everyone. It's like, I got 1 million tokens, I got to use them all. Our mission is the reverse. How can we get the token count as small as possible? Because that's the way you get efficiency. So it's sort of counter to the way things work today. So when I look at Gemma with 1 million or unlimited tokens, I think there are up to 1 million unlimited tokens. That's like the dream for a cloud provider, right? That's exactly what we don't want, right? We want to make it small.
So, Rich, being the devil's advocate, a lot of companies are going to say, my data is just not up to par. I need to clean it, whatever. How do you account for that? I know you have a solution.
Oh, you're not devil's advocate. You're my shield. Well, I'm so glad you asked that, because at least the work we're doing, it has 3 distinct phases. That Python program is also doing the filtering and cleaning. So we actually call it find and filter, analyze and process, and then report and recommend. Those are our 3 stages. Because the filter, someone mentioned before, the dirty data is like the end of the world, right? That's 90% of the time, that's all people are doing. This is where we do use a combination of large language models and Python. So typically, the large language model is very good at things like, here are all, for instance, we do inspect the dictionary, and we usually ingest that and say, here are all the ways you can say green for clothing, right? So you have to do some of that data work. I think data ingestion is the Achilles heel of all these things. And we spend a lot of time on that data cleaning front end, which is usually a combination of LLM plus code gen. So we use LLMs to basically generate flexible code that can process.
This is where I think there's learnings to be had better, because I think the trick or the technique that you were using of you didn't hear that is Ismail earlier, that they were saying what they do is they generate hypotheses about what a column is when they look at the database and there's no data, as the metadata won't accurately define what the column is. So they generate hypotheses, do dummy queries against the database, and then look what comes back.
Yeah.
And they found that to be very effective at basically filling in the gaps.
Yeah.
Because there's problems with data in terms of missing fields, etc. But the bigger problem is really missing metadata in these systems.
Yeah.
And so I was very interested to hear what you guys are doing there.
I think the metadata thing is one of the key things we learned to create more correctness. You need to have enough metadata and facts about the system before you ingest it. So I'm going to finish by talking just about what we call them chip shots, but the simple way to implement these things. And it's interesting that when you talk, I talk to a lot of people about this, and so many times you find this, it's sort of quality, cost, or time pick 2 problem. In almost all systems, you have to pick reliable software. You don't get a choice there. You have to have some minimization on cost. And so many systems are, well, we get flexibility by having an Excel layer, right? So anytime I hear someone using Excel, my ears immediately perk up, because that's not obvious opportunity to get rid of something that they're already doing that's very manual and painful. So the key thing that we do, and this is sort of our stages, we typically try to figure out how to make this problem divide into 3 stages, right? So there's silos of data. How can you find and filter it? We are, just so you know, our sweet spot is when you have multiple sources of data, which, by the way, is almost true everywhere. It's like I've got 3 trading systems. That's like Richard's dream. I've got 4 different ways to do SOC compliance. At 6 different, this is the best thing that ever happened to us, because that's what large language models are really good at. And then the second thing is the process and analyze thing, which is typically the business rule. And this is the interesting thing. The business rules in the companies we've talked about are actually not that complicated. It's sort of like, I want to cancel this product if my sales are less than 10% of my bestseller. It's just really hard to write that in Python code, right? And then the third thing is,
you were going to say something?
Sorry.
Not, I mean, and find and filter the data across several modalities sometimes.
Absolutely.
So multimodal.
I'm so glad you said that. That's my last slide. That's my last slide. Because sometimes it can be in images, sometimes it could be in video, sometimes it could be text. Right now, we're only working with text because that's people don't realize what you can do with text images, which I'm going to talk about.
Also, the popularity of libraries such as unstructured.
Yes.
Right.
Yeah.
So
Yeah. So then the third thing I think people don't spend a lot of time on is, this is, I'm going to thank Paul about this, is inevitably someone wants to generate an email and send them documents. You know, the funny thing is we do all these systems and notebooks and all this stuff. People just want to get back to their workflow. So this is actually, so again, thanks to Paul, but we think that most of these implementations will actually be Excel add-ons. Like literally in Excel, because you now, as Paul explained to me, you can host Node, et cetera, et cetera. And then you're just going to generate mail and Word just back into the workflow of a knowledge worker. Because no one wants to take the web dashboard and copy and paste.
This is our pre-sales. If you want to see what this notion of adding a user interface into Excel to extend it, stick around until 6 o'clock.
Ishmael's got a great demo.
Ishmael will demo that to you.
And the key thing is that
Microsoft finally has a decent API for
it's actually quite
Excel.
good. Yeah.
That you can now put real content into Excel and have it look like the native part of the Excel user interface. Finally, only 30 years later.
I'm amazed they do anything to improve Excel. Okay. And the punchline is you can write it in English. I'm going to show you this application we have. This will be the last thing. So this is a real application. It's in deployment. And I'm just going to explain what it is now, demo. So this is a recommendation system for retail. It basically says, by the way, these are the top questions that they ask. And this is a chart. And this is the actual code in English they have for how they do their business rules. If a product assortment percentage within 10% of the overall market assortment, then no change. And we actually copied this from an Excel, a PowerPoint deck. And this is our actual prompt we're feeding into the recommendation agent. So you can think about these little agents, and that's what's getting fed into the thing. So I've got 16 minutes, so I'm going to show it.
Overrun if you need to. Got some flex in the
You're
calendar.
hurting me. Okay. So this is it running live. Okay, so this is this inside edge component. Let me zoom it up a little bit so people can see what it is. So in essence, what we did was we said, what are the top questions that you asked? And this is a classic thing. They just wanted to get it. They're swimming in business intelligence crap, right? But they just wanted to get to the suggestion, which is, should I promote? By the way, just to talk about retail for a second, the big question is current product versus new product. The age-old question in that business, which I didn't know until we had a partner explaining this. And the question is are new products better than my carryover products? By the way, this is a little depressing. Turns out the products at the end of life have higher sales than the products they're keeping. This is a problem, right? And what we basically do is we ingest, to answer your question, we inject a gigantic SQL Server database. Turns out they only want these summaries. So that's what the thing operates on. I want to show you how it's different. So this is the normal demo. The difference, though, is there's agents that are running and doing the following things. How is the data actually aggregated? Right? We actually, remember we talked about that, the check system? We actually have a background agent that's saying, are there problems with this data? Right? Because those are the kinds of things that make people comfortable. So we'll actually go through and say, how is the data aggregated? What were the choices? Right? Just to pick on another one. Sorry. So this is a very nice one, right? Has all the charts and segments and things. But let's look at the range segment by total sales. Right? So the main thing that we've done here is if we look at these top sales and you go through the thing, you see the method, how the methodology was provided. By the way, this is my favorite. It says the analysis assumes the period column is in this format and the data is complete and accurate. Turns out, by the way, in this particular data set, Steve, it's not true. There are many cases where there's broken data. An example, we discovered this using the system. About 10% of their SKUs has no start date. So if you ask it, what is my earliest selling product? It says January 1st, 1900. Right. So that's the filtering thing that you immediately begin excluding those things. Now, the interesting thing is, if you were to ask, and this is the sort of the chat part of it, what is newness? By the way, does anyone know what ChatGPT would answer here? It would say new products, yada, 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 right? And I guess he's left, but this is the corpus problem, right? Newness in this thing has a very specific definition, right? So there's an agent that's now running that's actually pulling, here's what we mean by newness, and here's what it means. It's actually pulling rules. And what it's telling you is, this is very key. We want to first demonstrate we actually understand what the question is. Let's go ahead and finish. We want to demonstrate we understand what the question is. Right, so this is a classic enterprise thing. Do you even know what I'm talking about? This is not something you'd put in, recipe chatbot. So you're explaining newness, and then it actually explains in the domain of fashion, this is what it refers to. And this term's range segment and style colors. That's actually a defined term in this industry. So we're basically saying we actually know what you're talking about, and then you say it's why it's used, and then we explain the method. Again, very important. We tell you the columns we pulled out of the database. Because how many times have you looked at these summarized things and it's like, I didn't mean that column, I meant the other column. Right. So having these agents run in the background, the interesting thing about this, having agents is the right way to do this, because you don't want to run this main line. That's crazy, right? You want it to answer the question, but putting all this together is why we have to do this orchestration thing. Right. Here are the main reasons. And now it's going to document the execution of it. And it's going to say this data is structured in a tabular format. And it basically explains to you what it is. This is where the behind the firewall data is super important.
When you think about what you need to run this as an organization, things like lifecycle monitoring for all the different models and the components, and version control for.
You are my favorite shill of all time, because the answer to that is everything that you see here. By the way, if you go to LangChain, it's like, where is the data stored? I don't know. So our system is completely based on this. By the way, is the actual code for that expert. It is actually a manifest file. So it's a static file. Those of us who are computer scientists know, means you can inspect it, you can operate it. It doesn't have a version dependency. And they're all stored in this little thing called GitHub, which is a very nice place for managing versions.
Vaguely heard of it.
Yeah. So the system, we've been modifying open source so that the backend stores actually just Git. By the way, this solves all the multi-user problems immediately. It also means that all of our backend systems can operate on this, and we can do background checks. So this move to a manifest-based system that lets you operate on this, and by the way, this is the actual code, right? That actually lets you operate on this is really the key to success, right? So the thing that LangChain, for instance, or LangGraph does, which is actually produce Python code, that is, it's got to work for this version and that version. We're just generating, following Kubernetes and Helm and all these other things, a manifest style system, which makes it much more maintainable.
And what about things like the meta model management stuff?
Oh, okay. So I'll just show you how that works. So I'm not going to show you. It's all available. By the way, I guess I should show the actual user interface too at some point. Just so you know, the way you create this, there is a very nice studio that lets you create these things. So this is actually the code that was running. And so it has, a classic interface. We just stole it from someone else. But what it's actually generating are those manifests. So this says, please read the handbag data, generate some code, generate some markdown, and so forth. And so there's a whole collection of these things that generate these static files. But to answer your question, you can actually look at it in this way, which tells you the prompts that are being used, but you can also just access it with GitHub. Just take a look at it. So basically, all of these applications are designed so you have two ways to look at things. You can look at it just the static code. So here's the experts. Here are the things that are running. You can take a look at them and so forth. So you can operate it textually or you can operate it graphically. Most of the users will operate on it graphically, but it's really convenient to have these kinds of things, have version control all there. And I'm 9 minutes away, so I'm done. Questions?
I got a question, but for Donnie and Ivan, what do you guys think? What are your thoughts on what you just heard?
He's totally wrong. You should go home.
So to be honest, I operate kind of at a very low level relative. Like I think actually like Montley is sort of operating in the same domain of solving the AI applications proper. We're kind of more on the MLOps and foundation layers.
As soon as I heard your thing, what I thought was, this is why it's important to layer. I can see us being a customer of your stuff, right? Because you still need this MLOps layer actually operating. Right.
Yeah. For automation and training and that kind of stuff. Yeah. I ultimately, I actually think that like there's something to be disrupted about the like traditional consulting model that it sounds like you're doing a little bit of, where you're working with a consultant that can actually do a lot of the activities about this that have to scale with humans, like actually sorting out the data story so that it can be ingested in a single place, and then finding the common denominators between the companies you're.
And about half of our downstream partners are actually consultants who are seeing sort of the end of this model, and they want to get in the model, the world of business modeling, having proprietary models. That all sounds really good to them. So I agree. So I think there's a stacking thing that's really happening, and it's a huge deep stack. I mean, all the way down to San Manova. I mean, there's a gigantic stack of things that need to come together.
Yeah. And then I think a different piece that the whole industry is moving towards is just not using the largest language models on the planet to predict the next token of Old MacDonald had a land. Right?
There's no reason for that. For Taylor Swift and why she's famous.
Yeah,
we don't need that.
So I like generally like I think actually the methodology the methodology of like get the product working as like a product with the best possible model that you can, and then figure out how to optimize the system in the way that you described is I think the one we're going towards.
That's kind of my thinking as well. I think the stuff you described about working with the data, definitely we're feeling the same.
Yeah, no, I was actually glad to hear presentations because I wasn't inconsistent with you, and I think it all works. I have to leave one last slide, which is the actual measurement of the system, because enterprise companies don't work with real numbers. So our original alpha goal was being 75% on a list of ad hoc questions. I guess he's gone now, and just be consistent 4 times. That was our goal. When we actually launched the thing, we discovered we were 96% accurate and 100% accurate when all the bad data was present. So all of our problems had to do with, oh my God, it answered correctly. It did say that your oldest lifetime product was January 1st, 1900. It's just that's not useful. Yeah. Right. We then asked about consistency. And this is actually a very important thing, which is when you keep asking the thing, how much does it vibrate? Right. And so we were 97% consistent. Turns out we were never wrong. And this is the thing I'm most proud of. We were never wrong. We never hallucinated. If it didn't know, it didn't know. If you look at the inconsistency, there are some questions in the corpus that were really hard to answer, like what do customers want in December? Turns out that is a very vague question. And sometimes it answered the highest unit sales product, sometimes it answered the highest revenue product. And by the way, the consultant we work with disagreed as to what they meant. For humans, like one lady's like, oh, I mean units. The other guy's like, I mean revenues. So there's actually a real disagreement. And then we went to beta test with 10 people banging away on it. And we discovered it was 100% accurate as long as the question was in our training set. And the way this thing works is, if it's not in the data set, it just says, I don't know what's going on. Right. So I think when we're all developing systems, you do have to get to the punchline, which is, can I really trust this thing? And I think that's been the Achilles heel of AI, because of course, how do you trust these things? Final summary is a small agents help you with a lot of things. One is it helps you with memory size, and reliability. The second thing, it helps you with moving to open source models. And the third thing is it makes reliability engineering a lot easier, because you're only trying to test reliability of a single unit. And those of us who've ever been in any of these systems, if you got a big blob, it's really hard to test. You really want to slice the thing up to know what's going on. So
I'm conscious that there were 8 diamonds last time. This time there was only 3. Does that mean we got 36.5? We got a few percent of the way through. Well, you need 4 hours next time.
We'll never leave you with more slides. Of course, we got a lot more slides. We got raw on walls. We got revolutions. I got all kinds of things behind here.
Ben, were you gonna add some stuff?
Actually, a very silly point. I wanted to make a correction to the slide with results. You probably should replace word question to answer in the beta test line.
Oh yeah, sorry.
Because the questions are in
Thank you, that's bothering me. I got it.
Sorry, because I read it. I'm like,
yeah.
But I had actually other question. If that's okay. So it's very impressive result, and what I'm interested in is clients that you work with. Do they use the same kind of terminology in terms of how they formulate questions? Because that's the problem that we found is we analyze investment memos, we analyze a lot of like investment research, etc., and people write very nice sentences and words in there. And then when analyst actually wants to ask system a question, they would rarely use full words. They will often swear, and it's just very different terminology.
Yeah, just to give you that perspective. So the actual answer question was done by Indian speakers, and none of it's grammatical. None of it makes a lot of sense when you read it. And that was one of the big challenges because, I'm looking at the sentence and, I'm first generation Chinese, but it didn't make sense to me what the question was. So a lot of the work has a lot to do with the hard tuning on what do you really mean by this. And so there is a piece of the model that is basically reformulating the question into English. So there's actually a very important, I don't have time to go through the whole architecture. We actually first put prompt guard in front, and then we reformulate the things into English, the proper English, and then we feed it to the system. And the trick, of course, is we have an agent for each one, so we don't take a lot of memory.
We're going to have a short break now, so people, Rich, thank you very, very much for that. And if anyone's got questions for Rich, please feel free to throw them at him.
We're here to share.
But going to take a quick break. Zen's going to drive with shift line. I think we'll probably reconvene in what, 5 minutes, 10 minutes?
5 minutes, good.
Yeah.
I think this is the answer to your image question.
Good for 5 and make 10.
We're doing this with a company where you
so
put pictures,
right, he's
generate a description, and then you put notes.
Somewhere nearby.
Somewhere nearby. Right.
It's actually with the jet act as well.
Together with the CTO.
Yeah, but actually changed with spring.
Our buddy Miguel, the CTO at NVIDIA,
yeah, he's here.
Yeah, it's using a
Is the ranger, the organizer?
No.
Oh, no, he's
It's me. And
okay, so
music like the rest of us.
thank you very much. Well, what next? Can I grab your
no.
Well, I've got your connector.
Don't you owe me
I know.
17,000 quid?
I do.
Voting in Florida.
That thing has saved me so many times though. Those older Macs, they don't have.
Menu Apple.
That's okay. That's impressive that most of
He's trying to get his friends to.
good job. Got the point across really well.
He'll do his part.
Big thing is that I saw it. So we really have to have a class at Oxford.
Yeah.
So many companies.
Thank God.
Then